Hello and welcome back. In this video, we're going to talk about the second most important topic when you talk about object-oriented programming, and that is inheritance. So these are the topics which I have listed. You're going to see on upcoming videos. This is the introduction video. Okay, so what exactly inheritance is, where do we use it, how do we use it, we're going to see in this video, okay, with a basic example also. So let's get into it. Inheritance. So first of all, what exactly inheritance is? It is nothing but using an existing piece of code. Okay, it has some benefits like you don't have to make any effort to write the same code multiple times. Okay, it reduces the cost which is required to build the project. Yes, build that software, and it also enhances the reliability. Okay, so we no longer need to prepare, or we no longer need to require to rewrite the code, debug the code, and retest the code again and again. Okay, so whatever the code we have already coded, we're going to use it multiple times for different test cases. Okay, so this is what inheritance does, or yes, this is what inheritance does. So the same piece of code, like we have like we can say, like I want to have some data from the previous class. I don't need to initialize those data again and again. I can use the data from that previous class. Okay, so now here we are not going to use the functions, we're going to use the classes for the data of the classes basically. Okay, so let's suppose reusability, we're going to use the same particular class in different classes, and this Python supports the concept of reusing existing classes. Whatever the existing classes which we have pre-coded, now we're going to use in the same code. Okay, so the technique of creating a new class from the existing class is called as inheritance. The technique of creating a new class, we're going to create a new class which is already from the existing class. Okay, so this is what inheritance is. So when we talk about inheritance, we have different type of classes. So we have two important class, that is the base class, from which which is already existing, and then we have derived class. Okay, so what this particular diagram over here shows is that we're going to use the data items, or we're going to use the methods which are present in this, and this. I'm going to use all the datas and all the functions in this, and will be used in this derived class. So these are the existing classes, and this is the new class which we have prepared using these base classes. So the base class is called as the existing class, and the derived class is called as new class, or the new class is called as derived class, or the existing classes are called as base class. So this is very much important, two easy terms, that is base class and derived class. What are base class? Which are already created and which we're going to use in the new class, and derived class are the derived class which are derived from the existing classes. Okay, so this is what exactly inheritance as a picture look like. Now when we take an example, like we have a person, that person is a doctor and is also a patient. That person can also be a doctor, can also be a patient. That doctor can also be a dentist and can also be a surgeon. Okay, can you understand? Like the inheritance specifically shows the is a relationship. Okay, when we talk about inheritance, it is nothing but an is a relationship. That means a person is a doctor and a person is a patient also. Okay, so over here what you can see is this person is a generalized class. So this is what exactly containing everything, a general class. Then we have a specialized class where the doctor can be a dentist and can also be a surgeon. Okay, so this is from generalized to specialized. So this is what exactly is top-down approach. There are basically two type of approaches, a top-down approach and a bottom-up approach. Top-down approach is what we are given the problem, and we are dividing that problem into multiple cases. Okay, that can be a top-down approach. When we talk about a top-down approach, generalized class are designed first, and then the specialized class are derived by inheriting the generalized class. So we are inheriting this generalized class into this specialized class. So this person can have its age, can have a age, can have a gender, and something like this. So this person is male, then it is a doctor, or female is a doctor, then patient can be a male or a female, like this, So the data, so the personalized or the generalized class is created first, or designed first. Okay, so this is the base class over here. Whatever the data, whatever the functions are in it can be utilized by the doctor as well as dentists and surgeons. Okay, because these are the specialized class which are derived from this generalized class. So this is nothing but a top-down approach. Okay, so the derived class inherits all the capabilities of base class and adds refinements and extensions of their own. So when we talk about surgeon is specialized on something. we say, like dentist is specialized in something, so it is also going to take the inherit the what the functions or the data of its of the parent also, but also it is going to inherit or refine something, some extensions of its own also. Like dentist is specialized on teeth or oral. Yes, so this is what dentist is going to do. You know what I mean to say? Like a derived class, this derived class has the capability of the base class. That dentist is also a person, but it is also specialized in oral diseases. Yes, so this is what I mean. Moving forward, what exactly I said is there are two types of approaches. There are bottom-up approach and a top-down approach. Bottom-up, let's take this example of functions. Yes, we have three functions. These functions are first created and then we have created this main function. Yes, functions does the bottom-up. Yes, functions follows bottom-up approach. If we create a small functions first, and then we could talk about our main program. But when we talk about classes or inheritance, there we use top-down approach. We create parent first or the generalized class first, then we talk about the specialized classes. Yes, or we create the base class first, then we talk about derived classes. So this is the difference between bottom-up and top-down. Bottom-up creates the small parts first and then focuses on the main program, but the top-down creates base class first, then talk about the rest problems. Yes, so these are two types of the observation here is in bottom-up approach. In bottom-up approach, the main derivable is at the top. Okay, in bottom-up, the main derivable, whatever we want to derive, is at the top of the hierarchy. But in top-down approach, the main derivables are in the bottom. Whatever we want to focus on is at the bottom in top-down, but in top and bottom-up. Yes, moving forward. Now, how exactly we write inheritance? So for inheritance, we have this particular syntax where we have a class that is a derived class and this is the base class. So we're going to inherit something from the base class. So how do we inherit that? We use the parenthesis. In that parenthesis, we write the class name, that is the base class, and then we have the body. Very simple. We'll take an example. Let's go to interactive shell and understand this example, what I mean to explain you. Okay. Yes. Yes. So here the demonstration of inheritance, very basic example I have taken about a person and a student, or just a person, I guess. Okay. So let's see. So we have a person class, which is, yes, we have a teacher and a student. So that person can be a teacher, can also be a student, right? That person can be teacher, can be student, but they both inherit the same property of person. Yes, they can have a name, they can have an age, but teacher can have some, research experience, research area, what I mean to say, and student can have its course. So these are the refinements. We are using this name and age as the, what I mean to say, as the base property of that person, and then we have some research area and then the course name for student. So in person, that is the derived class, or sorry, this is the base class. Okay, so base class is not having any type of parenthesis and is not taking any type of argument, right? This is the base class which is having some initialization and it is taking name and age. Any problem? No. Moving forward, then we have a teacher class which is derived from the person class. This is the teacher class which is derived from a person class, which is inheriting the name and age of the person. Okay, so we have initialized a person also. Okay, so this is important that we invoke the class. Yes, so we have the person also, initialization of a person class also, and then we have some more refinements of the teacher class, that is the experience of that particular teacher and the research area of that particular teacher, and then we display a data. Similarly, in person class also we have some data to display. Okay, so we have a function display, and then we display the data about that person. Then we have for teacher class, that is the derived class, we also have a display data that is of experience and of research. So we're going to input the age, the name, okay, the experience in the research area of that particular teacher, and then you're going to print the stuff. Okay, then we another person we are going to talk about is a student class. Okay, student class is also inheriting the properties of person, and hence we have invoked the relation. Okay, and then we have some refinements, like we have a course name and we have the marks of that particular student, and then we are displaying the data. One thing to understand, like we are also going to display the we are not okay, when you see the main program over here, we have never made the object of the person class. We have already we have just had the objects for the teacher class as well as the object for the student class. We haven't had any data, yes, or any initialization of the person class, because the person class is already invoked in the base derived classes. Like over here we have initialized the person class, we have here initialized the person class, and we have also had the name or the function to display the person details. Okay, so we have two things, like Monica, the age, the experience here, because she's a teacher, so Monica, then we have its age, we have its experience, and then we have some course that she is having expertise on. Then we have a student, which is a Ross, which is having some age, and then we have the course name, and then we have the marks she got. Now let us run this program and let us understand what exactly we have got. I hope it's not going to take time. Yes, we have. Yes, we have the name, we have the age, which was, we have the teacher, we have the name of the teacher, that is Monica, we have her age, then we have the experience she has, and then we have the research area she is into, and then we have the student data. It is also having name and age, but you should understand, like the name and age are on the person class. We haven't derived or we haven't initialized anything of name and age in the student class, right, or in the teacher class. They are derived from the person class, that is the base class. And then we have some refinements, that is course and the marks. This is very much important. The syntax is very much important, that you need to invoke the classes, the base class, in your derived classes. Like this is the invoking of the base class in the derived class, like person, all the data should be initialized, and then we have the display function also. Okay, so the syntax is important, that like you need to have this parenthesis if it is a derived class, like it should say like it is derived from the person class, right? So this is it. This is the program which I was talking about. Okay, so this is important. So instead of writing the base class, you can also specify the expression like module name dot base class. If you have like the class, the main class is written on the, or the base class is written on a different module, you can write like the module name and the base class. This is very much easy. You can do it by your own also. Okay, you can use like import the module name dot base class, whatever the class you want to import to. Okay, so this is inheriting class. Now when we talk about inheritance, two more important concepts come into play, that is polymorphism and method overriding. What exactly polymorphism is? It is nothing but generally which is having different forms. Let's take a very basic example. I haven't included the example in this, but I would like to tell you. The first example which I want to tell you is the example of plus. Okay, the arithmetic operator as well as the string concatenator. Yes, you have plus as an operator which is adding integers. Also you have plus as an operator which is merging two strings also, which is concatenating two strings also. So this is polymorphism. We have the operator, the plus operator is having two forms, one which adds the integers and one which concatenates two strings. Yes, so this is nothing but polymorphism. Okay, one more example which I have taken is over here is date. The date can be a fruit that you eat and also a calendar that you see. Okay, now what exactly polymorphism helps us? Polymorphism enables a programmer to assign a different meaning or usage to a variable, function, or an object in the different contexts. Okay, we will take an example in further videos, I guess. Now what is the difference between inheritance and polymorphism? While inheritance is related to classes and their hierarchy, polymorphism on the other hand is related to methods. Okay, so inheritance is related to classes and its hierarchy, and the polymorphism on the other hand are related to the methods. Methods are nothing but the functions which are inside the class, right? So we have these two things. Polymorphism is related to methods, while the classes are related, or the inheritance is related to classes and the hierarchy. Hierarchy is nothing but the division we are doing, right? We have a person class, then we have a student class and a teacher class. So this is hierarchy. You have a grandfather, then you have father and uncle. So this is in hierarchy. So this is the difference between inheritance and polymorphism. So when polymorphism is applied to a function or method, depending on the different parameters of a particular form of function that can be selected for execution. Okay, so in Python, method overriding is one way of implementing polymorphism. So if you wanna implement polymorphism, you should know what exactly method overriding is. So what is method override, or what is the relation between inheritance and polymorphism? Let us see this first. Okay, so in Python, the word polymorphism, when used with inheritance, means defining a number of subclasses that have method of the same name. Like we have a teacher class, then we also have a teacher class, but it have different functions. Okay, the first teacher is of science and the second teacher is of computer science. Okay, so there, yes, both are teachers, but these teachers have different specializations. Like, do you understand? So in Python, polymorphism means is used when inheritance means defining a number of subclasses that have methods of same name. Okay, so a function can use objects of any of the polymorphic classes, irrespective of the fact that these classes are individually distinct. So these are individually distinct, but we have the same objects. Okay, so thus in Python, one way of providing polymorphism is by method overriding. Okay, in which a derived class method has method of the same name as specified in the base class, but given in a new meaning. Yes, we have the display data where we are displaying the age, and in second method we have the same display data, but there we are displaying the name of that particular person. So we are using the same method, but we both have different meanings. First we are having the, you know what I mean is, first we are having the age, and then we having the name, right? So the most important thing when inheritance and polymorphism come into play and overriding come into play is the scope. You must understand the scope of that particular class. What exactly is the scope of that particular function, or the, you know what I mean, or the method, right? So when we talk about method overriding, so method overriding is the ability of the class to change the implementation of the method provided by one of its ancestor, right? So this is it for this video. In the next we're going to talk about types of inheritance. I hope you understand what exactly I mean by polymorphism and method overloading. If you don't, you can visit my website eatsleep4repeat.blogspot.com. You can find the link in the description, the first link in the description. Okay, so yes, thank you.